Hello everyone. As I have discussed the 50th question of 2019 physics paper, hope it is better to be done in English for English medium students. And my English may not be very fluent, but I will try to make it reasonable. Okay, let's move on to the question. This is the 50th question of 2019 A-level paper. A small object is placed inside the right circular cone with axis vertical and vertex down as shown in the figure. So as you can see, there is a small object on a surface of a cone. The surface is inclined. The coefficient of static friction between the inner surface of the cone and the object is mu. What is the maximum angular velocity of rotation of the cone about its axis for the object to be on the inner surface of the cone without slipping at a distance d away from the axis? So here what they have said is there is a small object on the inner surface of a right circular cone. So imagine if the cone is not moving and the object is on the inclined inner surface of the cone. So if the cone is not moving, the object is tend to fall down due to its weight. But in this question, they have told us that the cone is rotating. So when it is rotating, the small object on the inclined inner surface of the cone will get a centrifugal force. That is normal. When there is a centrifugal force, there should be a centripetal force also. So centripetal force is towards the axis and centrifugal force is away from the axis. So what you have to know is, if the cone is rotating, we have to consider the centripetal force is supplied by its weight and its friction. First we have to take the free body diagram of this picture. So we'll move on to this. The mg is the weight of this object, and the arrow along the D is called centripetal force, and the other arrow is there to represent the normal reaction. So what you have to know is there is a part of weight that is acting towards the vertex of this cone, that is mg cos theta. And when we are going to talk about the friction, there is a normal reaction. The equation for the friction is F equals mu r. So the normal reaction will be, there is a straight part from the weight, that is mg sin theta. And then what you have to know here is, since the cone is rotating, the small object on the inner surface of the inclined surface will get a centrifugal force. When there is centrifugal force, it will make a pressure on the inner surface of the cone. So it will be added to the normal reaction. So we take like this. So this is a normal mechanic question with the second Newton law. Here F sum ma is used. So we have to take the forces. As I told you, mg cos theta is the force that is acting along the inclined inner surface of the cone towards vertex. Then we have to take the friction force. Imagine if the cone is not moving, the object is tend to fall down, so the friction will act on the x pathway, as I have drawn it on the upper part of this picture. So the friction will be on the x direction. But here when the cone is moving, cone is rotating, the small object will try to go out of the corner at the x direction. So the friction is holding the object on the inner surface. So friction is also acting towards the vertex. So since it is acting towards the vertex, it is a positive force. Mu, then the normal reaction. Normal reaction will get mg sin theta, that is a direct part from the weight of this object. Then centrifugal force is acting outward the axis. So centripetal force is the same as the centrifugal force, is acting towards the axis. So centripetal force itself act a pressure on the inclined inner surface of the cone. So it is taken as md omega squared cos theta. Then that is equal to ma, mass, into acceleration. So acceleration can be taken, it is a normal thing. If it is rotating in the angular velocity of omega, it will take the linear velocity as r omega, in here d omega. Then the centripetal acceleration will be r omega squared, or here d omega squared. So ma is md omega squared sin theta. The centripetal force is acting right angles to the axis, so its sine part is taken in the direction of vertex. That means in the direction along the surface of the vertex, surface of the cone. So as we have done here, we have taken all the forces acting along the inner surface of the cone. That means along the inclined surface. So then we can solve this equation and we can take the answer as this one. I hope this is answer 3 here. So what I did was, I took all the forces that is acting along the direction of inclined surface. It contains the force that is given by the weight and the friction that is acting against the force by which the object is tend to move away from the cone. So those things can be equalized when those things can be taken into an equation of F equals ma. That is the thing.